All right, so I'm going to show you how to set up one of these, what we call first principle models. Here, they don't tell you that this is exponential, but it's bacteria, and they've told you in the notes that bacteria have exponential decays and growths. So there's reasons for that, which is explained in your reading. This is a problem from your homework, and I'm going to show you how I do it. I've already polluted you with the way I do things, so you guys are already there. So first thing I do is I like to see things in a table format. So I put hour like this, and I'm going to add to this table as I go. Take the time to do this because it's going to save you time later. So go through and put this in here. So hour, I get 0, 1, 2, 3, 4, 5. And number of bacteria, I have 1,500. So it looks like it's decaying. 250, 125, 62.5, and 31.25. The story, I'm going to read the story second. Here, there's 1,000 bacteria in every cadet sink. Your friend from another regiment measured how many bacteria remained in his sink every hour after he sprayed it at midnight the night before Sammy. Okay, so he sprayed it, and you see a decay in the bacteria. Now, assume that each hour, every bacterium has a 50% chance of surviving to the next hour. Develop a first principles model to determine the amount of bacteria. Well, here, the bacteria are decaying. I'm going to have to make some assumptions, and I'm not looking at their solution, actually. I'm going to say that my fit, step 1, is to determine model type. I'm going to assume that this is going to be a type that looks like this. The P of T is equal to A B to the X plus D, or I'm going to put T here, time. T equals time, and here hours, because they said so. A and B and D have meanings. P of T is going to be the number of bacteria in hour T. You have to define your variables. If they're not defined, that's an automatic points off. But in general, for modeling, I have to define my variables. You guys asked me the same thing for the Bayesian modeling case that I showed you. Step 2, let's go back to black, is to fit this model with assumptions. The D is kind of the hardest thing to fit. And I'm going to assume that whatever they sprayed, it's killing everything. So it's a reasonable assumption for me to say D is equal to 0. On an exam, it's even more, because if you have to fit the D and it doesn't look like it's going to map to anything, it's going to be a lot of work. But I'm going to assume that it's 0. So now my model looks like this. Like that. Now, I'm going to use the data directly. Step 3. Fit data. I've got to get better at doing this, but let's see if I can capture this stuff here. How do I do that? Yeah, it does do that. Copy. Oh, wait, I don't want to do that. It has a little bit of a delay. So let me figure this out. I've been wanting to figure this out for your class. And then I'm going to go to the next page. Oh, I didn't want it to paste that. I want it to go to the next page and paste here. Doesn't seem to want to do that. There we go. I figured out how to do it finally. Okay, so how do I do the model fit? So the first thing is that P of t equals AB to the t. If you don't remember this, the A is going to be times 0. But in case you don't, you just stick in t equals 0, gives you P at 0 is equal to AB to the 0, which is just A. And we know that at time equals 0, right here, that we have 1,000. And P at 0 is equal to 1,000 from the data table. So A is equal to 1,000. That's my first conclusion. So now my model looks like this. Like this. So next part, I can take any one of these points. I'm going to choose the next one, this one over here, because ones and zeros are easier to work with. So I know that from the model that P at 1 is equal to 1,000 B to the 1, which equals 1,000 B. I know from the data that P at 1 is equal to 500. So putting the two together, I have 1,000 B is equal to 500. So B is equal to 500 divided by 1,000, which is equal to 5/10, which is equal to 1/2. So B is 1/2. So my final model, and I'm going to put it up on top here so that you can see it on the same page and I don't have to do this copy paste business again. My final model looks like P of t equals 1,000. B was 1/2. And I put it in decimals to the t. That's my prediction model. Now, you don't have to do this, but I could actually just put in here prediction at time equals 0. I'm going to get exactly the same thing because I fit it that way. At time equals 1, I actually fit that as well. I know that I'm going to get exactly 500. Well, what am I going to get at 2? Well, I'm going to go over here and put 1,000, 0.5 to the 2 and crank that out. So let me just crank it out on a calculator. I get 0.5 raised to the 2. That's going to give me 0.25, and then times 1,000, I'm going to get 250. So it's an exact match. You could do it for any of these time points. All right, so this is my first principles model. That's the first question. I did this slowly, but you can do it much quicker. The second question they asked is they asked some stuff with Excel trend lines, which you can't do on the test, but they asked how much bacteria will be left after 8 hours. Well, I know how to do that. I'm going to take my prediction model, and this time I'll copy and paste this. Whoops. Let me do undo. Let me copy and paste. This time I know how to do this. There it is. So I'm not going to get rid of this other stuff that's underneath it. Well, maybe I do because it's bugging me. All right, so I'm going to take that prediction model and then crank in 8 hours. And I know you guys make fun of me for saying crank it out, but that's okay. Make fun of me. It's fine. So I go to my calculator, the government issued cadet calculator, and I'm going to put 0.5 raised to the 8 first, because order of operations says exponents go first. And then I'm going to multiply that times 1,000, and I get 3.9. The next one they ask you is, if Sammy starts at 6:30, when would you have to spray to ensure there were no living bacteria in your sink at the beginning of the inspection? Well, that's kind of a hard question, because what they want to do, they have to assume something. So they're going to assume that the bacteria falls below 1. So, because it's never going to touch 0. If I actually plotted it, 0 is the asymptote. So they make an assumption, but what they really want here in this question is they want you to set your y value equal to something. And how to do that. So how to do this next question. And I'm going to finish this problem off at this question. You're trying to solve for the number of hours where this equals 1. If you do 0, it's not going to work because it's asymptoted at 0. So it's never going to equal 0. So it's going to fall below 1. So they're assuming that their 1 is good enough. And what you do is you isolate this exponential part of it. So you go 1 divided by 1,000 is equal to 1/2 to the t. So isolate this. And then next step is to natural log both sides. And you don't have to natural log, you can log it, but we're in engineering school, you should natural log it. And then you use log laws to say that this side's actually just a number. I'm going to crank that in a second. You can make fun of me again because friends saying crank, but I get this. The t comes out in front. And then I divide both sides by this natural log 1/2. Like so. And so my t is this ugly number, so forth. I always like to think about why I got this far in math. And I think one of the reasons is I was not afraid of ugly things. When I got it just as a number and I knew it was a number. So if I just take that natural log 1 divided by 1,000 and divide that by natural log of 1/2, I get around 9 hours. On a calculator. Okay, so don't be afraid. Those are just numbers. Treat them, if you want to change them to decimals right away, you can change natural log 1/2 to a decimal. You can change natural log 1/1,000 to it as a decimal and then keep going. So that's the way to do it. So I got 9.97 hours. Yeah, that's about 9.9 hours. About right. Their answer is right. All right, I mean, the interpret was exactly what, it's an exact match. I'm going to go to an SSE problem next so that you can see that generated. And I generated also some sample questions for you that are similar to your homework. So I'm going to send all this out to you, but this is an example of how to do an exponential model, first principles from beginning to end.